All right, physics, here we are on experiment number 4. And in this lab, we're going to choose 3 resistors that have the same value. And we're going to put these into this table and fill it out. And then we're going to do some measuring of them. So the 3 resistors that I've chosen are these 3 guys here. And it asks us to put their colors in here. So the colors in order are orange, orange, brown, and gold. Orange, orange, brown, and gold. So write those colors in here. Then look up on the table. Pause the video if you need to and figure out what the resistance of these resistors is. That's going to write down the coded resistance. Okay. Now, we're going to do the measured resistance. So I'll set that up here in just a second. All right, here we are set up to measure the 3 resistors. You'll notice the steps here actually are numbered 1, 2, 3, and this is hiding the instructions. You need to follow the instructions there as 1, 2, 3, and 4. And for this step, we are going to measure the resistance. So for the first resistor, the measured resistance is 328. The second resistor's measurement is 329. And the third one is 328. All right, so follow the directions hidden here by this about calculating the percent error and so forth. All right, now on the resistor is this gold mark is supposed to give you the coded resistance as you saw in the picture when you figure out the resistors. Now, we're supposed to connect the 3 resistors in a series circuit, and we're going to test the resistors. So here we have it in series, and we know what each individual one is. So now we're going to measure across resistors from 1 to 2. That's what these little subscripts. That's not 12. That's resistors 1 and 2. So let's measure from 1. That would be 1. And this would be across 2. So 658 here. And then we want 2 and 3. So there's 2 and 3. 658. And then we want 1, 2, and 3. So let's go all the way across. And we get 987. And knowing that there's about 330, we should be each about 990. And that adds up. We just simply add resistors when they're in series. So our next set of directions say to construct a parallel circuit, first using combinations of the 2 resistors, then using all 3. Measuring, record your values. All right, so let's take this. I'm going to try to fit this all on the screen. A little tricky. So you can see we've wired these 2 resistors with a wire connecting the 2 so that these 2 are in parallel. We're going to see, it doesn't matter where I put the tester, as long as I'm on both sides. So I could do it here. See, it's 164 there. It's 164 there. So you need to write down in this spot right here, 164. Now we're going to test 2 and 3. So let's just switch it here to 2 and 3 and see what the resistance is. It's 164. And then it asks us to test, it notes to say try 1 and 3, but we're going to get the same results. Notice that that does 164. But the last one here is for 1, 2, and 3. So let's get 1, 2, and 3. Wire that there. And we have all three of them in parallel. Let's see what the numbers are. Let's go across there. 109. 109 for those. All right, on to number 7. Okay, for number 7, it asks us to set it up where we have one resistor that then splits into two resistors in parallel. So we have series and parallel. These two are in parallel that are in series with this resistor. I try to set it up to look somewhat similar. You can see this resistor is to represent this one. These two resistors are representing these two. I connected them here to represent that connection. We'll measure across each one. You need to write them down in here as resistor 1 and so on. So resistor 1, what would you predict? Resistor 1, 328. Now across resistors 2 and 3, so 164. And what about all the way across from 1 and across 2 and 3? We get 493. And the reason why is we get 1 over R resistance here, and then we have to add that to this resistance. So notice, what is 328 plus 164? So the first resistance was this combined at 164 plus the 328 gets us a total of 493. Okay, for the back side of this lab, you've got 3 different resistors. We got to do 3 different ones instead of the same ones. And I'll let you take a good look here. And I'm going to go back and forth, and you can pause your video to write down what the coded resistance is. And the colors are, for the first one, is brown, green, blue, black, gold. And here is the color coordination for what they are. Let you decipher that. Our next one is red, red, black, gold. Red, red, black, gold. So here is the chart. And then our last one is brown, black, black, gold. Brown, black, black, gold. So then you can use this chart here to decipher that. Okay, we're going to measure each one of these. I've already got the first one right here. So write down the coded measurement. The measured resistance. That goes right there. So, and then the second one, we're going to put in right there. 22.2. And the third one, 10.3. All right, now that we've got those 3 things measured there, written in there, you can calculate the percent error, and the tolerance is based on the gold. And now we're going to set up this circuit. So I'm going to set it up. We're going to have it all in series, and then we'll start doing some of the measurements. Okay, so here we have resistor A, B, and C, and we're going to measure the resistance across A to B. So let's see what that is. It's at 37.0. All right, from B to C. 32.6. So this should be the adding of those two resistances. And then we're going to go all across all three of them. Huh. $47. Let's see what that wasn't holding still. 47.1. So that should be adding the 15 plus 10 is 25 plus 22 should be 27. Yeah, so that's all of them added up together. All right, now we're going to set it up to go into parallel. So like the last one, we're going to set these guys up in parallel. To do that, I have to connect them from here to here touching and from here to here. And we have to connect these two down here. And these two down here. Now they're all in parallel. Now, they say to first test just A and B. To just test A and B, I have to disconnect those two. So here we go. We're going to go across A and B. So it's 15. 15.1. That doesn't sound right. Something is wrong. Okay, so we've got these in parallel, and this one is about 15, and this one is about 22. So we should expect a resistance lower than either one of those, and sure enough, we get a 9.1. So those two together are 9.1 ohms. And then we got to do B to C. So we're going to go these two here, and see what we get. 7.6. And then we've got to get all three in parallel, A, B, C. So would you predict the resistance to be larger or less than 9 or 7? Doesn't matter where I touch it here. Should get the same results. 5.1, 5.2. So let's go with 5.2 ohms. Notice that with parallel resistance, we wind up with less and less resistance. This is one of the reasons why when you continue to plug in one thing after another into an outlet, eventually there's too much electricity coming through and it'll melt the wires coming to the outlet because it's drawing more and more electricity because there's less and less resistance. All right, in this space I want you to write answers to two questions. Why does resistance go up when in series? And the answer is that every time we add a resistor, we make it more and more difficult for the electrons to go through. Therefore, we are adding resistance. And then why does resistance go down when in parallel? Well, every time we add a resistor in parallel, we're creating one more path that the electrons can go. So it gets easier and easier and easier. And the resistance total goes down, even though each individual resistor remains the same. All right, we got the back page to finish up. So let's set up for that. Okay, so now they've asked us to set it up in series, two in parallel that are then in turn in series with that resistor. So here we go. Let's set it up that way. So here we have this this is resistor A, and then we split to go two different directions for resistor B and C, and I'm going to connect them together let this in so that I can see what the lowest point is together, and try to show you what the resistance turns out to be. So we're going to do the resistance across A, which should be what it was in the beginning. That's not resistor A. That is resistor, oh yeah, that's resistor A. So that's 15.1, which is what we expected. Then we're going to go across B and C, so from here to here, and that is 7.2, which is something we played with before. And then across the whole circuit, it is now 22. So if you add 15 plus 17, you get 22. So you can see how this total resistance gets added to that one. These two get reduced, and that's how we get the 7.2. All right, that concludes our lab. Turn it in.